Hello and welcome to my talk. Today we're going to speak about a lot of things that I would like us to do better. Whether it's going to be 33 things precisely, I'm not so sure. You know, you have to come up with a nice title to be accepted at such a great conference as DevOps. But what I'm sure about is that on the one hand, we're going to learn how to code better, and on the other hand, which is more important, we're going to learn how to raise the bar on a daily basis. So before we begin, let's have the boring part done, and let me introduce myself to you. So my name is Tom. I work for SBB in Bern in Switzerland. It's like a national rail provider. You can find me on Twitter under @TomBujok. And guys, at least 10 new followers today. And you can also visit my blog, refisio.org, when you can read some more stuff about the projects that I'm doing. Okay, so let us begin. Let us imagine a situation that we want to order a wardrobe. And we go to a craftsman. It has to be handmade, and we say, I would like to order a wardrobe. But, you know, it doesn't have to stand straight. It may be like the Leaning Tower of Pisa, so that I'm going to push it into the corner so that it doesn't collapse. And when it comes to the wood you are supposed to take, you can take any bits and pieces. It doesn't really matter. You don't have to fit the doors. If you have the doors, you can fit one, or you can fit two of them, but they do not have to look alike. And when it comes to the paint or varnish, just don't put anything, or you can use any colors. It doesn't really matter. So the first rhetorical question that I have to you is, what would we think of the guy if we just, came in, placed this order, and the guy accepted it? So what I would think is probably the guy is not a serious craftsman, or he simply doesn't have enough work, so he's going to take any order in order to earn some money. The question number two, we can invert it, of course, and we can ask, what would the guy think of us if he was a serious craftsman and we just showed up and placed such an order? He would probably think, we are kidding, or we are joking, we are making fun out of him. Or that simply we are mad or crazy. So having this small illustration in mind, let us challenge the statement that I have prepared for today, which is the code that we produce is bad. And I don't mean it's always bad. So if you are a geeky coder and your code is always picture perfect, well crafted, and fully tested, don't be offended. I mean it's frequently bad. It's often bad. It's like very often bad, or most of the time bad. So, if you've worked recently for a serious financial institution, like a big bank or like an insurance company, you can probably testify together with me that the code looks like a big ball of mud. It's like a spaghetti code jungle. And whenever John, an average IT guy, working for an average IT company, let's say a big bank again, has to take like a nice piece of engineering that you can see in the picture, and maybe a manager comes and says, John, we are expecting some high traffic next week, so we have to add some more capacity to our system. So he can take the system as it is, well crafted, and he can turn it into an absurd within a couple of hours by injecting a caching bin on the top. So what is the reason? What is the reason why we produce the infamous enterprise code, the quality of which is really bad? The first thing I would like to mention is that most probably we still do not have well-defined standards. Like if I told you I would like to build a vehicle, and I told you it has to have 2 wheels, you would immediately say, oh, it's a bicycle. But if I told you, no, it is supposed to have an engine, then it's a motorbike. And if I tell you it has to have 4 wheels, it may be like an SUV car, or like an estate car, like a convertible, like a truck, lorry, or any kind of car. There's thousands kinds of cars. Whereas when we begin to work on a project, and it's our first day, we try to import it into our IDE, and after 8 hours, if we make it compile, and we finally look at the code, after 1 or 2 hours, we probably, in 90% of the cases, we have no idea what's going on there. The second example, I can bet with you that I can find a battery of a car, like maybe 90% of the cars, within 1 minute because I simply opened the hood and I look to the left, oh, it's not there. So I look to the right, oh, the battery is there. Whereas if somebody tells me, listen, Tom, you just have to find the properties of the transaction manager and you have to tweak them. I'm going to have a look maybe at some properties files, maybe XML files, maybe some string context, maybe some container configs, or who knows where. The second reason that I want to mention is that we pretty often work under tight time or business pressure. Tight deadlines are there. And, if we draw another illustration, and if we have like an construction engineer, and we tell him, listen, here's the valley, and we have to build a bridge over it. But we tell him, but listen, every second car may fall into the river. It doesn't really matter. We just simply have to do it within the next 2 months. Will the guy accept it? Most probably not. Whereas John, our guy, he will simply, open the IDE and say, oh, this is the method I have to fix. Doesn't matter, the class looks nice, it has like 10 methods, 10 lines each. Then we simply have a big method, 150 lines, cache the requests, and it's done. So we can most probably mention thousands of reasons, but what about our skills? When it gets down to our, low-level skills that we are using and, deploying every day at work, is our conscience clear, or can we do a bit better? Let us have a look at the football players as a profession. Who can tell me if they would be that good as they are if they didn't train on a daily basis? If they simply played a game every weekend, let's say every Saturday on Sunday, without any training. So I'm really into football. I read a lot of interviews, for example, with Cristiano Ronaldo. And what he says is when he learns a new trick, he trains, he tries it in the training and he fails, and he tries and he fails. And after 2, 3, or 6 months, when he finally gets it, he tries this trick in a game. And what they learn in a game is simply, it's the experience that comes on the top of the skills. But you cannot be a great football player if you do not train, if you simply play the game. So on the example of the football players, we can say that deploying our skills is almost mutually exclusive from mastering them. And you may tell me, yeah, but what does it have to do with the IT industry? And I can give you an IT-related example right away. Let's say your boss comes to the room and says, we have to release a new version of our project in 10 minutes. And you have, let's say, 30 Maven submodules. And as it is with Maven, the version of the parent module is always hard-coded in the children modules. You cannot basically reference it. It's really there as a string. So if you didn't know, let's say, Maven release plugin, or if you didn't know find, grab, set commands, you'd probably think, yeah, I have like 10 minutes, I have 30 modules, I can open every file, I can just modify the string, I can save it, I'm done in 4 minutes, I commit it, and it's good. You will not probably try playing with Maven release module, plugin in these 10 minutes, because it's highly probable you will not get it. It needs some training. It needs some practicing. So basically, when you have your skills, you simply deploy them in these stressful situations. So I hope I encourage you that we have to practice on this example, and we can also go one step further, and we can quote Aristotle, who said that we are what we repeatedly do. Excellence, then, is not an act, but a habit. Basically, in order to be excellent, we have to be excellent every day. Our habits have to be excellent. So what is a habit then? A habit is a routine of behavior that are repeated regularly or tends to occur subconsciously. So if I'm driving a car and I'm turning left, I'm turning on the left indicator. I don't have to think about it. Or if the car in front of me is braking, I'm not thinking, oh, whoa, the gap is closing between us, what should I do? I'm going to Google it, how to brake? No, I'm basically press the pedal and I'm braking. So this is a habit. And when we are speaking about habits, we have to say there are good habits and bad habits. And our good habits are good, so we probably do not have to play with them, but we're going to play with our bad habits a bit today. So when it comes to the bad habits, Catherine Murdoch, who wrote the book The Psychology of a Habit, she said that basically we have to recognize the bad habits and eliminate them as soon as possible. Because the older we get, the less flexible we get, and the more difficult it gets really to eliminate this habit. And what she also said is that each repetition of a bad habit leaves its mark, which means that the more we repeat our shoddy techniques, the more we simply learn them, so it's more difficult to eliminate them. So how can we really eliminate a bad habit? Dr. Michael Russell, who basically said that we cannot really erase a habit. So if I code up a builder pattern 10 times in the wrong way, I cannot simply say, yeah, now I'm going to code it up in a good way the next time, because I don't know how to do it. It's still a bad habit. So according to Dr. Michael Russell, we basically have to learn a good habit, and we have to override the old one with the new one. So we cannot simply erase it. We simply eliminate the bad one by learning the new one and overriding it. And when we learn the new habits, we insert them into our habit loops, into our everyday jobs, so that we can, use them every day. So let's recap the theory part. We stated that the code that we produce is mostly bad. We tried to find a couple of reasons. We could name thousands of them, but we basically focused on our skills. On the example of the football players, we said that we have to practice in order to get excellent habits. And we quoted Aristotle, who said that in order to be excellent, we have to be excellent every day. At the end, we said that in order to eliminate the bad habits, we have to learn the new habits, the good habits, and we have to override the old ones with the new ones. And that's basically the thing that we're going to try to do today. So what we're going to do, we're going to look at some technologies, frameworks, and languages. We're going to simply touch upon them, just to give you the gist, what is there, what is available, what we can use, so that you can deep dive and select the things that you like. I will not present the bad habits because, as I reckon, you are all software engineers, so you can, imagine the bad implementation, the brute force implementation in your heads. I'm just simply going to show you the good habits, and yeah, I hope you'll like it. Okay, so the first technology we're going to have a look at is Lombok. Let us have a look at the person class. It's a DTO, data transfer object, or a domain object, whatever. This will not compile because it has final fields and no constructor, but it doesn't matter. So in order to make this class usable, you probably need some constructors, depending on how you're going to initialize it. You probably need like an equals and hash code if you're going to store it in a map or a list. You probably will need some getters to get some values and stuff like this. And if you have a lot of domain class, it's a lot of code. With Lombok, you can add some annotations, and these methods will be added right for you. And you may think, okay, but I can't see the code, so how can I use the IntelliSense when I use control space in my IDE? How will I see the method? So there are plugins for Eclipse and IDE and IntelliJ, so the methods will be visible. You can use them. And you may say, yeah, okay, but it's a lot of annotations for a couple of things. There's also a data annotation that means all the other annotations that were presented in the previous slide. So if you can use Lombok, and you have a lot of domain classes, and you don't want to code up the boilerplate code, which is like getters, setters, standard equals, standard hash code, all the things that you normally click like code generate in your Eclipse or IntelliJ. You can use Lombok, and you don't see this code. It's pretty similar as in Groovy, and yeah, it works great. It's tested in production. It works with Hibernate as well, so I highly recommend it. The other thing that it's there and it's really nice, it's the builder. So if you want to use the builder, like here, as you can see, the person builder, coding up a builder is like a static inner class that's long as well. You have to have methods for every field, and then you have to have a static method to get the builder and stuff like this. So even for a couple of fields, it's probably like 100 lines or a bit less. With the builder annotation, you get the builder out of the box. So it's pretty slick and neat, and you can use it right away as well. The last thing, or the second last thing that I want to show is a log4j or a logger annotation. It's similar as it is in Groovy. You basically annotate your class with @log4j, and you don't have to type the private static final log equals logger get factory get log for class and stuff like this. This is boilerplate code in every class where you need a logger. With this thing, you simply annotate, and you can use the logger as presented here in the slide. And this is the last slide when it comes to Lombok. So let me ask, who is still using Java 5? If you could raise your hands. Yeah, there are some people. 6? Yep. Okay, so this is for you. Because in Java 7, there's try catch with resources statement, where you can basically put some resources that implement closable, and they will be closed after the try block. So you don't have to have the try catch finally try catch, because even close may throw an exception. So for you, if you're using Java 5 or 6, you can use the cleanup annotation, and basically the resource will be closed automatically. So you don't have to add the boilerplate code that looks the same all the time, like try, finally, catch, try, catch, finally, yeah. So I'm not going to ask who is using Java 4, because some people may get a heart attack or something. Okay, so this was Project Lombok. A couple of convenience things that I have presented. There's like thousands of them, or hundreds, or maybe tens, but there's really a lot of them. And have a look, and yeah, it's pretty neat. The next library is Guava, implemented by Google, or the employees of Google. It's pretty cool as well. A lot of convenience that or things that are better than in Commons Lang or stuff like this. Like the standard things I will not present, like Commons Lang or Commons IO. I guess everybody had already looked at it. So Guava has one cool thing, or two or three things that I'm going to present. The first thing is optional. So if we have a map, and let's say we have a key that is a string, and we have a value that is a string, and if I give a key and get the value and it's null, what does it mean? Did somebody insert null, like put null into the map under this key? Or is it simply like this, that there's no value? Basically, there's no key and no value. We don't know it. So with optional, we have, it's like a simple thing. We get a reference, we get an object that's not null. So on the one hand, we basically, when we put values into the map, we can know when there's a key and value, and there's only key, or there's nothing. And on the other hand, if you have a lot of methods that return null, you can use optional so that people think, can think about it when they use the method. May it return null or not? If you return an object, they will probably ignore it, assuming that there will be an object. With optional, if they see an optional in the declaration of a method, they will most probably, try to think about, okay, there may be optionals, or there may be value or not. So I don't want to convince you to use optional. I mean, there are people who love it, there are people who don't like it. But basically, if you want to use it, it's already implemented by Guava, so you don't have to, implement it by yourself. Although it's like a one class or two classes, it's still cool to use something that's tested. Yep, the other thing is the preconditions for validation or checking the input values. It's really cool. You can check the argument, and there's a condition, and you're going to get a string with the error message if it's not there. And what I really like is the last line, where we check not null, because we do not waste a line for the check. It basically checks whether it's not null, but it also returns the reference out of the box. So if it's null, it's going to throw an exception. But if it's not null, we can assign the result of the method, which means that we are basically not wasting a line for the validation of the nullable argument. So the last thing that I'm going to show is are the multi-maps or multi-collections. So I guess everybody had a case when they had to store, let's say, a set or a map in a map. So you had like two maps, one map that was stored in a second map. So when you have this case, what you have to do if you want to add a value to the inner map, you have to first check if the map exists. If not, you have to create it, and then you have to insert it into the first collection, into the first map. which is also like a boilerplate code as well. I mean, it's the same everywhere, and you have to code it up all over and over again. With multi-maps, you have 3 collections out of the box, which is a map of a list, map of a set, and map of a map. 3 examples in the slide. And yeah, they are there, they exist. So if you have this case, you don't have to handle it, per hand by yourself. You simply use something that's implemented and test it. Okay. The next thing that we're going to show you is Lambda J. So I didn't ask who is using Java 8 in production or in development. Yeah, maybe 3 lucky guys. So yeah, so they released it, but when will we be able to use it in production? But if you want to use some lambdas, or if you want to filter some collections, you can use Lambda J, pretty neat and small framework that adds some functional flavor to Java. You simply add a jar and have a couple of things. So the example that I'm showing here is like how to filter a collection in a functional way. It's doing some crazy stuff in order to make it working, but it looks great. And in some cases, you don't have to use a for loop and then an if and then check your collections, and then create another collection to put the result and then to return the result. In this case, you have it out of the box. It is using some proxy if you are interested, for example, to record the invocation of the getAge method in order to invoke this method on every object then to check the condition. It's pretty cool. But what is cool is the second example, because you have a closure in Java 5, 6, or 7. It's basically, if it wasn't for this colon, it would look like a closure, but the colon has to be there. And, like the parents could be skipped. It's basically just to make it look nice. And yeah, the way it's implemented, it's using some thread locals and stuff like this. So it's basically kind of not very neat and slick implementation, but in order to overcome the limitations of Java, yeah, they did it and it works. There are also some more complex factories that are not using thread locals, but it's a closure. So basically it's a function that we can store as a reference, and then we can apply it. Like you can see in this example, you basically have this closure println and apply it on each of these objects, and it's gonna invoke this method. So if you can use it, you can play with it. It's pretty nice as well. The implementation is very nice with tests, and you can even look at the code. It's a very nice code. So yeah, if you want to use some functional things and you are not supposed to use Java 8, you can use Lambda J. A lot of convenience there. Okay, logging. Let us quickly go through this part. Who can tell me what the difference is between these 2 lines that are highlighted? I don't have a gift for you, but if you know, just raise your hand. Yep. The first will print the toString of the exception, and the second? Yeah, exactly. So the second will println the string and then the stack trace. So the first one will not println the stack trace. It will println the toString on an exception, which means we're not going to see the stack trace. And you can see, hundreds of such lines in production systems. And then you see an exception. Oh, an exception. You see the name of the exception, but you have no idea what caused the exception. So in Log4j, there is this risk. With SLF4j, for example, or Logback, you don't have this method, so you don't have to watch out for it. You can basically enter a string, and then you can enter the exception. In this case, I'm presenting 2 things at once, because the SLF4j also adds the parameterization to the message, so that you don't have to use string format. You can use this parens for any argument that's passed here, and the last one is exception. But this one, using an object on which the toString method is invoked, is not there. Yeah, which means that if you use it, you will see stack traces everywhere, and not only in places where you put the message with log4j. Okay. The next part is bad defaults. Yeah, basically, if you generate a try-catch block in your IDE, you get exception print stack trace. And you may think, yeah, okay, you can always change it, but you see, these lines over and over again in production code. And it means, okay, you're going to see it in your log, but the system will not recognize that something bad happened. It's just going to be println and the processing will go further. So I thought only Eclipse does it, but IntelliJ does it as well. You can change it, of course, in both of the IDs, and you can throw, for example, a runtime exception so that it is properly propagated, and you don't see the exception only in your log file. Pretty neat, pretty cheap, to change it, but then you omit the mistake. Yep, this is a pretty nice example. So who has ever seen it in a code, in a production code? Yeah, exactly. That's cool. So what I always do when I see it, I do something like this, and I commit it without talking to this person, and I guarantee this person will come to your desk to discuss it. And and during this discussion, it may be a bit short and rapid, but it never stayed like this. Because the discussion begins, yeah, but it's sure, but not so sure to put system exit, blah, blah, blah. So, it works like a charm. So you don't have to delete it and discuss it, just commit it and wait, for the reaction. Okay, and the last bad default that I want to present is that everything is public. I mean, yeah, an ID generates a class or a method or a field maybe not, but a class and a method that is public over and over again. And I mean, it's not necessarily bad, but if something is supposed to be public, you will have a good reason to make it public. And if it's not public, you can begin with private or package protected. And if you see, oh, it has to be public, you will change it. It's easy to change private or no modifier to public. But if you have everything that's public and you have to be backward compatible, you are, making an API available, then in order to be backward compatible, it has to stay public forever. All the methods have to be there. So what I do is I basically generate package protected methods or even private methods, and if I see they have to be public, I switch them to public, and works like a charm. So these are some puzzles. There's thousands of them in these two books, so if you haven't read them, I highly recommend them to you. Effective Java by Joshua Bloch and Clean Code by Uncle Bob. There's a lot of examples. I don't want to present the ones that are in these books, but yeah, have a look at them. It's really worth it. So now we're going to move a bit into the testing area, and the framework that I'm going to present to you is called Spock. And you may think, okay, but it's a Groovy framework, but you can use it in Java as well. And you can code up, almost Java code in your tests. The tests have to be compiled with Groovy, but when you see the test, you will see why I like it. So who has ever tried to parameterize JUnit test with the standard mechanism? Yeah, some people, where you return like a collection of arrays where you have to put objects, and even putting all the things there is so cumbersome that yeah, no comments. So with Spock, it's pretty easy. Basically, you put what you expect, and this is the input, and this is the result, and you can have this table here. You can put more arguments and more columns, and basically, it's going to take every line as a symbol, like a single test case. If you add the unroll it here, in your IDE, you're going to see every line that's included here as a separate test. So the test will be unrolled. So if you want to test some convenient stuff like helper methods and stuff like this is like a really perfect case. And what is more, if you unroll it, you can even include the input in the name of the method. So in your IDE or in Jenkins, when you're looking at the test, it's not like this that it's a generic test. You're going to see everything as it was a separate method. And it's really neat for testing of such things as presented here. And the second thing that I forgot, I'm going to present it in the second slide as well, is this expect and where kind of DSL. So you don't have to put like, given, when, then in a comment like in Java, or expect where, or set up when, then. It's a part of the framework, so it has to be there. So, you don't have to make people, if they code up like tests that I see recently pretty often, that there's a test with 3 for loops, and there are some, combinations, and there are like 10 different asserts in different places, and you basically don't know what the test is doing. So even if you try to tell them, code up small tests for each case, and include given, when, then. Yeah, I mean, it's just the best effort. You tell to do it, and you don't know whether they're going to structure the test like this. With Spock, it has to be like this. Yeah, there's a second thing here, setup, when, then. And you can see some Groovy Mocks here that are really nice, who check that this method was invoked only once. Of course, you can do all of this with Mockito, Java, JUnit, and test-ng and stuff like this, but I simply like it. You can have your code in Java and code up some testing Groovy. And also, if you begin with testing, it's not like production code. So if your boss is hesitant to accept Groovy as a language, you may code up more and more and more tests in Groovy. And when you see, okay, I got it, I want to use it, it's really cool. When you see the features and advantages, it's really easy to start coding up logic in Groovy, like the business logic production code in Groovy as well. Okay, so what I'm going to present is the Unitils, a really neat framework. For testing as well, it's pretty stable. There's been a couple of releases. The convenience that I'm going to present here is called file content. Basically, if you have a string in your test and you want to read the content of a file to an attribute, to a property of a class, you basically use the file content annotation, and it's going to do it out of the box for you. You can even specify encoding and stuff like this. Works pretty well. The second thing is temp file. So if you need a temp file for the time span of the test, you don't have to invoke it by yourself. You don't have to use system temp file or whatever. You simply annotate it and you have it out of the box. So the only drawback of this framework is that you have to extend the Unitils JUnit4 class. So if I mean, it would be much better with an annotation or with a runner or stuff like this. Maybe it will be refactored, but yeah, for some cases it's pretty neat. The second thing that I'm going to show when it comes to Unitils is the reflection equals. So if you have an object and you don't have an equals or hashcode method that is, that is there, and you want to compare the object using business values, business key, not the reference, you can use the reflection, and and basically it's going to compare the fields using the reflection. The other thing is that you can compare the list using a linear order. So I guess everybody has once implemented a sort in a test in order to sort the list, in order to compare them, use a JUnit or stuff like this. You can use this one with a linear order, and you don't have to do such magic in your tests anymore. Yeah, so we are going quickly through the examples, but you can then look it up. I'm going to publish the slides as well, so you can then have a look at them. Yeah, so the last thing that I'm going to show when it comes to Unitils is the inject into and inject into static. So if you have a class, let's say a handmade singleton, that have a private static final field as an attribute, and it's like, so it's private static final instance equals and then new something, you cannot change it. You cannot inject a mock there. You cannot basically change the implementation of the singleton. It's there and it's done. But if you want to inject another object in order to, I don't know, throw an exception whenever the singleton is used to check some special conditions, you can use the inject into and inject into static, which will basically it will do it for you. It will change the implementation. It will change the reference of this object to the object that you are giving in the annotation. So it is pretty neat as well. In some cases, when you need it, it's kind of nice. Yep. So the next framework is called JUnit Params. And it's a really, really small framework, but what it's supposed to do is to make JUnit more usable when it comes to parameterized tests. And you can specify some parameters in this annotation, and they will be basically given here. So you don't have to implement this JUnit way of collection of object arrays and stuff like this. It's pretty neat. And if you need some more things, not only an annotation, but you need a factory of objects, stuff like this, you can use this one, which is called like a provider, or it's like a provider of objects, and you use this dollar notation to create these arrays, which is kind of a bit better than doing new object and then parents and stuff like this. So it's pretty neat as well. If you have to use JUnit and you want to parameterize your test, I encourage you to have a look at JUnit params. Which is basically much simpler than the JUnit mechanism, and works like a charm as well. Okay, so the next thing is called awaitility. So how many of you have ever coded asynchronous tests where you had to put some sleep, and then you had to have some atomic boolean, and then you had to wait with the assertion until the object has ended its processing and stuff like this? Could you raise your hands? Yep. So this code is ugly, guys. I did it as well. But don't do it again, because you have awaitility. And this is a really cool library. I really love it. And I started using it in business logic as well, when you had some conditions that you have to wait for. It's working like a charm, although the primary goal is basically testing. So you have this await method, and you can specify how many seconds at most or minutes at most until a method is called, or as in the second example, in the second test, until atomic is true or false. It's actually an atomic integer here. It's equal to 1 and stuff like this. So it's a really, really neat code, neat convenience that you can use in your asynchronous tests, and you don't have to put any sleeps and while true loops and stuff like this in your test code anymore. You know, this is really cool. Okay, and as we are finishing with the testing area of code, the last library is called Byteman. So it's not like this that I encourage you to use it all the time or often. But sometimes there are these cases where you want to test some conditions, and it's simply impossible to somehow play with the input arguments so that like a specific part of code is invoked. And it's simply so difficult to do it, or almost impossible, that you cannot test a part of the code. And with Byteman, what you can do is basically you can modify the bytecode of your production code, so that whenever, in this case, like a target method getQuote is invoked, an action of a throw new runtime exception is being invoked as well. So if you want to change the code, change the bytecode in order to specify some conditions or throw an exception, you can use Byteman, and it's going to basically invoke it for you. It's going to modify the bytecode. Whenever the method is invoked, it's going to throw this exception. And this one is expected here. And we have this getQuote method here. The exception will be thrown because of these annotations, and the test will be green. So you need to specify some stuff in your POM XML or in your class path to make it working, but it's pretty cool, pretty slick as well. And if you need it, if you have this special condition that you have to test, you can use Byteman, and you don't have to play with libraries that modify bytecode by yourself. Okay, so now I'm going to show some Groovy stuff. Basically one thing. I love Groovy. I think Groovy is really nice to do some things, for example, XML parsing. Not only, but this is the example that I'm going to present right now. So we have this very, very complex XML. And what we want to do, we want to print in the name of the banks. We want to just parse this XML, and we want to print it to the console. And if you Google it up, and if you want to do it like 100% standard Java way, this is what, like the Sun page, the Oracle page will present to you. And there are some really nice snippets here. Like, for example, as you see, in 2014, you cannot use the for each loop. You have to use the C-style loop. And then if you get a node, you still have to tape if this node is of element node and stuff like this. So, okay, I know there are some parsers. You can use them. But this is basically plain Java. And what I'm going to show you is plain Groovy. It would basically fit one line, and it is normally one line, but it wouldn't fit the slide. So, I had to split it. And what is really cool here, as you can see, you can basically navigate using the attributes of the XML element. So the stock element was the element of the XML, and you can simply print in the text of the element. So if you want to parse XML, and you want to navigate through the structure of the object, you simply use dot notation and the name of the tag, and you can use more of them in order to navigate deeper into the object, XML tree, in order to get the values. So, there's a lot of cool things if you want to start with Groovy, like downloading the content or an HTTP file within one line and stuff like this. So I encourage you to have a look at Groovy. I think it's a really nice language, and if you really don't want to use it all the time, you can use it for some things. Yep, so this is a second Groovy-related framework, which is called Grape. And it's really cool because you can use Groovy as a scripting language, for example, on a Linux platform. And with Groovy, you can write Java code, like mostly Java code. If you don't want to use the, like the idiomatic Groovy, you can do most of the Java stuff and it will work. So this is very nice because using this grep annotation, you can specify the dependencies of your script. So if your script, which is like, let's say a Groovy script, when you invoke one method, needs some dependencies like jars, like the ones that you normally specify in POM XML or Gradle file, you can specify them in the script and you can invoke the script and this libraries will be downloaded and added to the class path in runtime. So you can use your Groovy script as a Groovy as a scripting language in order to invoke some Java-related stuff, and it works out of the box. You can specify Grape XML or whatever it's called. If you have some repository with an user and authentication, you can add it there as well. So these jars will be basically downloaded as if it was Maven. Yep. So the last thing from the Groovy world is Maven versus Gradle. So I will not say a bad word about Maven. I did a lot of things in Maven. I managed to do everything in Maven. How long the POM was is another story. And whether I really fully controlled everything is the next story. But it worked, as it does in Gradle as well. The thing that I want to present to you is the length of a standard file where you define like a build or compilation and stuff like this. You can see that Maven is a bit more verbose. And yeah, I mean, I encourage you to start playing with Gradle. It's a really kind of a bit different setup, but it's much shorter. You can do a lot. You can do maybe even more than in Maven, or if I want to be politically correct, I would say you can achieve the same goals in a shorter way. Yep, so we are moving to the last category, which is tools. And the first tool that I'm going to present is Git. So in this slide, I present 20 Git commands. And Git is not really that complex or complicated. If you learn these 20 commands, you can basically start using Git right away. Okay, you should probably read 1 or 2 blog entries, how it works with the staging and pushing and pulling and stuff like this. But it's not like this that the learning curve is really steep. It is not, but it gives you a lot of flexibility and a lot of possibilities that you do not get with Maven. Like, simple branching and merging and stashing your changes while you want to change something else and commit it quickly. So if you cannot use Git as a server, you can use the Git SVN bridge, which is there out of the box and works like a charm as well. I use Git SVN every day because, we have SVN as the main server. All the people will not even notice, but you will notice that your flexibility and your productivity really grows. So if you want to try out Git, just learn these commands, read 1 blog entry, and you'll be good. The other thing is like Bash. So I know, we can do everything in Total Commander or any other tools or like, IDE or Eclipse. We can do full text search. But there is this day, when it's Friday and it's 4 p.m. and you have to go home and there's a problem in production and you are left there alone with a Linux console. And you have hundreds of files and you have to change 1 property. And, and when you then tried Googling around how to search this and that and how to do find with grep and then replace it with set, it will take you ages. So I really encourage you to learn a couple of commands. I listed here find and grep, find and set, or a bit of oak. It is not really that complex. You just have to, you have to try it out. You have to start playing with it. Because, when this time comes, you have to be prepared. So the last thing is, how many of you are developing software using Windows OS? Yeah, I thought so. I have to do it as well, although I would love to develop on my Mac. But, corporate policies. So that's the reason why I started the Baboon project, which is like a framework around Cygwin. I started using Cygwin because I wanted to use a console on Windows, and then I noticed, but there's a lot of, cons. You have to configure a lot of things. If you install some scripts, you cannot update them, and basically you have to tweak a lot of things. For example, to use some Git things, it's basically tweaking config files, and it's not basically transparent and repeatable. So if my friend comes and he says, what did you do with it? Oh, I cannot say because I changed some file and I don't know which file it was. So Baboon is like a plugin architecture around Cygwin. It installs Cygwin without admin rights, because this was my case as well. I didn't have admin rights, so I couldn't install Cygwin because it requires admin rights. And so I work it all around, and there's a lot of plugins. There's even like a package manager like apt-get or yum. I don't know if you know it. If you do apt-get install tar or stuff like this, it will install stuff automatically. I've been working for a couple of months on this, and the release will be next week. So you can basically, yeah, it's already working. I'm using it for the last 6 months at work, and it's pretty stable. So remember this link, Baboon GitHub.io, or simply Baboon with you, on GitHub, and you'll find it. Release next week. Okay. The last thing is IDE. So yeah, I know that we can do everything with the right click and with the context menu, and then go to implementation or find usages or stuff like this, but it's much easier, quicker, and cleaner to learn the shortcuts. IntelliJ has a really nice shortcut map that you can print out and stick it to the wall so that when you look at it, you learn a new shortcut. Or with IntelliJ, I'm not working for JetBrains, but I love it, so I'm advertising it as well. There's also a nice plugin that shows you when you're clicking with your mouse or opening an option, it shows you how you could achieve it with a shortcut, and which is kind of nice. That's the way how I really learn most of the shortcuts, because if you repeat an activity in your IDE, you see, oh, I can do it like Control-B or something, and then I know it. I don't have to look it up what kind of option it is. So I encourage you to really learn shortcuts because it makes your job easier and quicker. You don't have to click all the time with your mouse. So the last thing are the code reviews. I'm not going to speak about the technique, how you do the code reviews. So how many of you are doing code reviews at all? Oh, that's really cool. That's really encouraging. So what I see recently is like, it's like when people do the code reviews, I hear some swear words, I hear some shouting, I hear some attitude, no, it's right, no, it's wrong, you have to do it like this, no, it's total, no swear words. So, yeah, code reviews are the best tool to learn new things. So I really encourage you, if your attitude is kind of, defensive during code reviews, no, I wrote the best code and it's working, and somebody implemented it the same way in 2004 and it's still working. Yeah, but it's 2014 and we can change, the way we implement certain things. So the biggest problem that I see with code reviews is this attitude, no, this is fine. I did it correctly. Maybe you have a better way, but this is fine. So if we manage to change it somehow into, yes, please give me some hints. I'm really open to change the implementation because I want to learn something new. It really makes our life simpler. I learned a lot of things because I was open. I asked, okay, please have a look at this code. Could I do it in a better way? Do you know a trick how I could change it? And if our attitude changes, then yeah, I think code reviews work much better. Okay, so we have 1 minute 33 seconds left, and this is the wrap-up. So yeah, I hope I encouraged you to have a look at new tools, new technologies, new frameworks. The goal of this talk wasn't really to present, a couple of frameworks. It was more about, encouraging us to learn new things, to look at new things, and to stay up to date. There's always a lot of things happening in the Java world, and if we do not have a look at them, we will simply stay in the past and the train is leaving. So I would like to encourage you to have a look, maybe try out some of these tools, not all of them at once, so that other team members, do not get heart attacks. And if you like them, just tweet. You can tweet to me and then say, okay, I use this one and this is nice. I would be very happy. I would appreciate it. And the motto for today is that any jackass can kick down a barn, but it takes a good carpenter to build one. Okay, thank you. We've got 1 minute still. Any questions? Okay, I'll be available after the talk if you want to have some questions afterwards. Thank you.
If you have any question, we have... How many time do we have on the screen, please, Tom?
0 minutes.
We have no left. Donc on n'a pas de temps, je suis désolé. Tom sera disponible pour les questions et sur Internet et tout ça. Merci beaucoup.
Merci.
Sorry.